Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE May-June series of 2020, paper 42. Again, this is the structured paper, so it's 2.5 hours long. This is the worked solutions, so focus on how to set up the problems, how to think through the problems, and not just on the answer at the end. So here, number 1A, part I says divide $24 into a ratio of 7:5. Whenever I'm working with ratios, I like to put a total underneath, whether I use the number or not. And so there's 12 total parts. So we're going to divide the 24 into those 12 parts, which means each part gets 2. So 7 times 2 is 14 and 5 times 2 is 10. So the ratio is $14 to $10. In part II, write $24.60 as a fraction of $2,870. Give your answer in its lowest terms. You can do that right on your calculator. Don't forget your decimal, $24.60 over 2,870, and the calculator should reduce it for you down to 3 over 350. Next, write $1.92 as a percentage of $1.60. So a percentage of means you're going to divide by the $1.60. So $1.92 divided by $1.60 equals 1.20. Since you're writing it as a percent, you need to move your decimal over twice. So it comes out to 120%. Letter B, in a sale, the original prices are reduced by 15%. So again, remember, increase or decrease by a percentage is always from an understood one representing your 100% original. So we have a reduction of 15%, so that's minus 0.15, and that means we have 0.85. And it says, calculate the sale price of a book that had the original price of $12. So 12 is the original. We're going to take 0.85 times the original, and that will be our sale price. So the sale price ends up being $10.20. Notice I added the extra 0 there because we're dealing with money, so $10.20. Part I calculate the original price of a jacket that has a sale price of $38.25. So this time they gave us the sale price and we have to calculate the original price. So this time we want to divide both sides by 0.85 and we end up with the original price being $45. You should be able to think about this logically. Your sale price should always be lower than your original price. And so if you end up with that not in the right order, then you probably did something wrong. But the original price, $45, the sale price, $38.25. Part C, Dean invests $500 for 10 years at a rate of 1.7% per year, simple interest. Simple interest is I equals PRT. Calculate the total interest earned during the 10 years. So we're looking for the I part here, the amount of interest. So the P is the principal, that's $500, that's the original investment. Then the R is the rate, 1.7, move the decimal over twice, 0.017 to take it from a percent to a decimal. And then T is time, which is 10 years. Multiply all that out and you get $85 is the total interest for the 10-year period. Part II, Ollie invests $200 at a rate of 0.0035% per day. Notice this is in bold. We're so used to rates being per year. It's very rare that we see a rate in a different term. So it's per day compound interest. So we need to use the compound interest formula and we need to have our time be in days. So calculate the value of Ollie's investment. That means the total amount at the end of time, at the end of 1 year. So here's our amount after time, that is the final amount, equals the original amount, which is the $200, times parenthesis, here's our 1 for the original 100%, plus the increase in the rate. So notice this percent up here is 0.0035. Well, we need to move that decimal over 2 more places to go from a percent to a decimal. So now it's 0.000035. And our time is not 1 because our percent is per day. So we need to change the 1 year into 365 days. When you do this compound interest on your calculator, you get an amount total of $202.57. Part I, Edna, invests $500 at a rate of R% per year compound interest. At the end of 6 years, the value of Edna's investment is $559.78. Find the value of R. Okay, here's our end of time value, the 559.78. Here's the 500 is the original value at the beginning of the time. We have our 1, we have our 6 for the 6 years, and we need to put our R% in as a plus 0.0 R. We just move that decimal over twice. It's 0.0 R. It is not the word or. It is not OR. It is 0.0 R. And we're solving for the R. So we're going to divide this 500 since it's multiplying our parenthesis. We're going to divide the 500 to the other side. We get 1.11956. Then we're going to 6th root both sides. So on your calculator, you can either use the exponent key and raise it to the 1/6 power, or you can use the radical key and make sure the index number is a 6. So the 6th root, and you get 1.019, then subtract 1, so you have 0.019. Move the decimal over twice so that you get your R, which is 1.9 is the value of the R. Moving on, number 2, here we have vectors with this column vector notation here. Find 2p plus q. So here's vector p, here's vector q. So 2 times 4/5 plus a negative 2/7. You keep your components in the order they give them. So you have 2 times 4 plus a negative 2 going through the x component. And so you get 8 minus 2 is 6. Then for the y component, 2 times 5 plus the 7. So you get 10 plus 7, 17. So our new column vector is 6 and 17. It's not a fraction, so don't put the fraction bar in there. It's an x and y value of this component vector. Then it says find, and it looks like an absolute value sign. It actually means the magnitude. It's kind of like absolute value. It's your distance from the origin. So what is the magnitude of vector p? So we do the square root. It's just like your distance formula, the square root of 4 squared plus 5 squared. So we have 16 plus 25 on the inside, which ends up with 41. The square root of 41 is 6.403. To 3 significant figures is 6.40. Be careful when you're working with radicals and exponents. They do not distribute over add or subtract. So you cannot cancel the radical with these exponents because if you have a plus or minus in there, it does not distribute. Letter B, A is the 0.41, and vector AB follows the column vector -3,1. This is the directions on how to get from A to B. So now we need to find the coordinates of B. So we start with A, which is 4 for the x coordinate, and we're going to go back 3, so that leaves us at 1. Then we start at 1 for the y part, and we go over, or sorry, we go up 1, and so we end up at 2 for the y value. So that gives us the coordinates 1, 2 is the coordinates for letter B, which is at the end of the AB vector. Part C, the line y equals 3x minus 2 crosses the y-axis at G. So this crossing an axis is kind of a key term here, because whenever you cross an axis, the other variable is 0. So if you cross the y-axis, that means your x is 0. If you cross the x-axis, that means your y is 0. So it wants us to write down the coordinates of G. Well, we already know that x is 0, so all we have to do is plug that back in for the x. 0 times 3 is 0, and that leaves with y as being a negative 2. So 0, negative 2 are the coordinates of G. Letter D, here we have a diagram to do vectors with. In the diagram, O is the origin. OT is 2 times TD. So if OT is twice TD, that means it's a ratio of 2 to 1, which means the total parts are 3 parts, where the OT has 2 of the 3 pieces and TD has 1 of the 3 pieces, and OD is our vector D. Then OC is our vector C, M is the midpoint of TC. Find the position vector of M. Position vector again means from the origin, so we just draw that line in ourselves. Now we want to use the big letters first. How do we get from O to M using these other letters? So we can put OM, or we can put, first though, before we do that, we're going to come back to that down here. First, notice we don't have anything along here along the TC line here. We need to get a little bit more information for our TC. Since M is on TC, we need to understand TC a little bit better. So TC connects OC and OT. OC and OT are tail to tail. So that means we do end minus start. So from T to C is end minus start. So that's C minus 2/3 D. And then if we want to find T to M, which is half of that, half of TC, we distribute the 1/2 through and we get 1/2 C minus 1/3 D. Now we can go back and look at OM. OM, if you see here, is OT plus TM, OT plus TM. Now all we have to do is put it together. So OT is 2/3 D plus TM, we just found right here. We get 1/2 C minus 1/3 D. Combine our like terms and you end up with 1/2 C plus 1/3 D for the letter OM. So again, you want to use your big letters to help you figure it out first and then go to the little vectors. And also you sometimes have to figure out another line first before you can get to the part that you want to. Okay, moving on to number 3, the speed V kilometers per hour of each of 200 cars passing a building is measured. The table shows the results. So here you have these class boundaries. You have 16 cars that fall within a speed of 0 to 20 kilometers per hour, all the way up to 4 cars fall between 60 and 80 kilometers per hour. It asks us to calculate an estimate of the mean. Whenever you're working with mean and class boundaries, you need to find your mid-class boundary. So the middle between 0 and 20 is 10, between 20 and 40 is 30, and so on. Carefully calculate your mid-class value. In cases like this where you have decimals, the easiest way, if you can't just obviously see it, is to add the two numbers together and divide by 2. So when you add the two numbers, the two end of the boundaries together, divide by 2, that gives you the mid-class boundary. Then to find the mean, we multiply the frequency times the mid-class value, and we add them up as we go through all the classes. And then at the end, we divide by the total frequency. So we end up with 16 times 10 plus 34 times 30 plus 62 times 42.5 all the way through, and add those all up and then divide by the total frequency, which was 200. You can either add up the frequencies or just look at your problem. It says 200 cars. So you should end up with 8,280 divided by 200 gives you 41.4 is your estimate of the mean. Now we go down to a frequency table. So we're going to a frequency table, and we're changing it from frequency to cumulative frequency. So notice 16 plus 34 is the 50, and then 50 plus the 62 is 112, and then 112 plus the 58 is 170, 170 plus the 26 is 196, and 196 plus the 4 is 200. So you're adding them up as you go, and that's called cumulative frequency. Then when you graph it, you graph the cumulative frequency with the upper bound of your class boundaries. So since the lower bound is essentially a 0, you can't go less than 0 speed. 0, 0 will be our lowest point. And then we graph 16 with the 20, with the upper bounds. So we go to 20 and we go up to 16. And then we do 50 on the 40. So we come over here to the 40 and we go up and find the 50. And we put the 112 on the 45. So find your 45, which is right here in the middle. And it should have been up here at 112. And actually, I don't think my dot is that dark. It should be in here somewhere. And then put your 170 on the 50. Here's the 50. So here's 170 right there. Can see that dot pretty clearly. And 196 on the 60. Here's our 196 on the 60. And the 200 then goes on your 80, the 80 being our uppermost class boundary. Then you put those, connect those, try to make it as smooth of a curve as possible. You're going to be transitioning from a concave up shape to a concave down shape. And so you have to try to smooth out that curve as much as you can. And try not to make straight lines. Try to give it at least a bit of a curve, if at all possible. Now we have questions to answer. Use your diagram to find an estimate of the upper quartile. Upper quartile is Q3, which is 75%. 75% of 200 is 150. So notice I start here right at 150. Use my straight edge to draw a nice straight line over to your graph. Then turn it perpendicular and draw a nice straight line down. And that happens to come down at 48. So 48 is the answer to that one. Then find the number of cars with a speed greater than 35. So here's our speed, here's 35. We follow it up again using your straight edge to your graph. Then go perpendicular, follow it over. We get to 40. Now remember, we want greater than 35. Greater than 35 is on this side of the line. So when we come up over here, we're on the top side of the line. If you were less than 35, you would be below the line. But because it wants greater than 35, we want to be above the line. So we're going to take 200 minus the 40 to get the number in between. And we'll see that there were 180 and 60 cars with a speed greater than 35 kilometers per hour. 2 of the 200 cars are chosen at random. Find the probability that they both have a speed greater than 50. So let's go back up here to our cumulative frequency. Here is less than or equal to 50. So if we're going to be greater than 50, that means we are in these upper two. And if you look at the frequency within those bands, there are 30 vehicles, the 26 and the 4, 30 vehicles, or you could take 200 minus the 170. There are 30 vehicles in this range. So there are a total of 200 cars. So 30 of those cars have a speed greater than 50. So if you select one of them, it will be 30 out of the 200. Now you've already removed that car. So now there's only 29 cars that have a speed greater than 50 and a total of 199 cars. So that represents your second car chosen at random, and you multiply those together and you get 87 out of 3,980. That is your probability that both of the cars that you choose out of the 200 have a speed greater than 50 kilometers per hour. Now we have a new frequency table is made by combining intervals. So they went up here to this previous one, and instead of having 6 intervals, they made some combinations and they reduced it down to 3 intervals. So from 0 to 40, 40 to 50, 50 to 80, here's the frequency of the number of vehicles. It still adds up to 200 vehicles, and it wants us to draw a histogram. So on the x-axis part of your histogram, that just follows your boundaries, 0 to 40, 40 to 50, 50 to 80. So here's 0 to 40, 40 to 50, and 50 to 80. For the y-axis part, you need to find the frequency density. Frequency density is the frequency divided by the class width. CW stands for class width. So 40 minus 0 is 40, 50 minus 40 is 10, 80 minus 50 is 30. That is the width of these class boundaries. So you take the frequency divided by the class width. That gives you your frequency density. So we have 1.25, 12, and 1. Those are the heights of our histogram, and you draw those in as accurately as you can. I usually write the frequency density on top so that the person grading it can see right away what height you are attempting to reach. And you also have the scale here on the left. Moving on to number 4, we have this diagram with lengths and angle measurements. And it says the diagram shows 2 triangles. So I labeled them 1 and 2, which we'll get to that later. And it says calculate QR. So I put a little X here. We want to find this length. And right now we're working with the smaller triangle. And if you notice, we have a side, but no corresponding angle. Over here, we have an angle, but we don't know the side. Actually, that's the side we're looking for. And we have another side with no corresponding angle. So if you do not have a pair of both an angle and its corresponding side, then you need to use the law of cosines. If you did have a pair, you could use the law of sines. So we need to use the law of cosines. You should memorize this formula. It shows up on every test set of IGCSE. So you should get used to it so that you can get the points of those problems. So x is the side so that we're looking for. So it's going to be x squared equals, and then we use the other 2 sides, 150 squared plus 120 squared. This part, by the way, corresponds to like your Pythagorean theorem. But then we have this extra stuff from the law of cosines. So we have 150 squared plus 120 squared minus 2 times the 150 times the 120. cosine of the angle in between, and this angle corresponds with the side x. So this angle in the cosine needs to correspond or be opposite of the side that you put over here. So just calculate these numbers in your calculator. The 150 squared is one calculation. The 120 squared is a calculation. All this at the end is all multiply. Make sure your calculator is in degree mode. You don't want to be surprised if your calculator happens to be in radian mode or some other mode. So double check to make sure your calculator is in degree mode. Multiply all this out. And I multiplied these numbers first. You can go ahead and do the trig as well if you want. So here, these two numbers can be added together. 22,500 plus the 14,400 can be added together. You cannot subtract the 36,000 at this point because multiply comes before subtraction. So you need to do this cosine 25, which gives us this 32,627.08. Now we can subtract, and then we can square root. Of course, since we're dealing with distance, we only use the positive root, and we put it in three significant figures, which is 65.4. Now it asks us to calculate RS. RS is over here, so I put the letter Y. If you look, we have an angle 55 and 45. Since we have two angles, we can subtract them from 180 and get the third angle, which is 80 degrees. We now have a side and its corresponding angle, so we can use the law of sines. So we're going to use the 150 with the 80 and the y with the 55. So that gives us 150 over sine 80 equals y over sine 55. Multiply the sine 55 to the other side. Do all this on your calculator and it gives you 125 to three significant figures. Calculate the total area of the two triangles. This is where I labeled them triangle 1 and 2. Remember, area of triangles does not have to be the geometric formula. It doesn't have to be half base times height. You can also use the trigonometric formula for area of a triangle, which is 1/2 AB sine C, where A and B are two sides and C is the angle that are between the two sides. So here we have for the little triangle, A and B are the 120 and 150 times sine of the 25 degrees, which is in between those. So you do 1/2 120 times 150 times sine of 25. For the other one, we have here, well, we already calculated y. So we're going to use the 45, the 150, and our value for y. Here's our value for y. We're going to use the 124.768. So 1/2 times the 150 times the 124.768. Notice I used the number before rounding, or at least before rounding to three significant figures, and then sine of 45, which was the angle in between. So these all calculate out to the 3,803.564 and 6,616.822. Add those together and our total area is 10,420.386. To three significant figures is 10,400 meters square. Moving on to number 5, we have a diagram with triangles on one side and a little bearing thing over here on the other. So let's see what we have. It gives us some information here that you can read through. It's already put on the diagram. Find the bearing of D from B. So here's D over here, and we want to find the bearing of D from B. So we start at B because that's where we're coming from. So we put our north, south, east, west thing here, and we want to go from the north, rotating clockwise until we're facing D. So we need to find this little arrow here. Well, Before we do that, we might want to find this angle down here since we have a right triangle, and we can use our opposite and adjacent. So we can use tangent of 450 over 350. So from this theta, the opposite over adjacent, that's tangent. And you can calculate the angle out to be 52.125. That's this angle in here. And we're going to subtract it from 90 to get this little arrow on the top side of that. So 90 minus 52.125 is 37.9. And that's how far we rotate from the north. Since we're dealing with bearings, technically we're supposed to have 3 digits there in front of the decimal. So we're going to put 037, and with degrees, you normally go to 1 decimal place. So I'm trying to be consistent both with bearings where you use 3 numbers, 037, and also consistent with degrees where you go to 1 decimal place. Then down here, letter B, calculate the distance from D to A. So from D all the way over here to A, we want to calculate this distance. Well, before we get there, we need to kind of figure out this angle over here. And we already have the 400 meters, and we can also I believe I used the law of sines. I used the law of cosines, but we need to find D to A. So let's find B, D first. So with our B, D here, with our B, D, we can use the Pythagorean theorem. So 350 squared plus 450 squared and square root of that. So we start with that. So our BD is 570.09. So here we have 570.09. Now notice we have a side, but we do not have the total corresponding angle. We know the 50, but we don't know this little sliver right here. And for the 400, which was already given, we have this side, but we don't have the corresponding angle over here either. Down here, what we do know though up here is this 140 and this going due east is 90. So 140 minus this right angle here gives us 50 for down here, and this east and this east are parallel, meaning alternate interior angles are equal. And then since this is a 90, we can take 90 minus 50 and get the 40. Now the 40 and the 37.9 gives us a complete angle. So we don't have this little angle here. We don't have this angle over here, but we can figure out this one down here. We want to find what I have is 624. That's the answer. We want to find this missing piece. So we're going to use the law of cosines because we don't have a pair. So we end up with AD squared equals 400 squared. That was the given side, plus 570.09 squared. That was the hypotenuse of the triangle over here, minus 2 times the 400 times the 570.09 cosine of the 77.9, which was adding the 40 plus 37.9 together. So again, run these calculations through your calculator. 400 squared is this, 570.09 squared is this. All of this multiplied out here comes out to the negative 95,601. Combine all those, you get 389,401 square root, and to 3 significant figures, you get 624. Now, Juno runs around the field from A to B, B to C, C to D, D to back to A. He runs at a speed of 3 meters per second. Calculate the total time Jono takes to run around the field. Well, we know that distance equals rate times time. We're solving for time, so we want to do distance divided by rate. So we go all the way around the field, starting from A. So that's 400 plus 350 plus 450 plus 624. And you see that right here, 400 plus 350 plus 450 plus 624, divided by the rate, which is 3 meters per second. So you get 1,824 divided by 3, which comes out to 608 seconds. They want us to give our answer in minutes and seconds, correct to the nearest second. So we're going to take our 608 and divide it by 60 seconds in a minute, and we end up with 10.13 minutes. So 10 is the whole number. That's our number of minutes. The 0.13 is 0.13 minute. So 1 minute has 60 seconds. So 1.3, it's actually 1.3 repeating. The 3 is repeating, not the 1, just the 3 is repeating. So 0.133333 times 60 gives us 8 seconds. So 10 minutes and 8 seconds. So don't forget to convert your decimal from decimal minutes into seconds to get that answer. Now we go to number 6, which is on functions. Find h of 4. So we plug the 4 into the x here on the h of x, and we get 4 raised to the 4th power. You can do that on your calculator, and you get 256. Now we have a composite function, so we put the 1 into the g, and we get 1 squared plus 1, which is 1 plus 1, which is 2. Then we put that into the f of x, so we take f of 2 now, and we get 2 times 3 is 6, plus 2 is 8. Now we switch the composite function in a different way, and it wants us to find the form ax squared plus bx plus c. So we take our f of x, which is the 3x plus 2, and we put it into the x in the g of x. So that gives us a 3x plus 2 squared plus 1. Don't forget the little plus 1 at the end. And we need to multiply this out. Again, remember, exponents and radicals do not distribute over add and subtract. You cannot just distribute the exponent. You need to multiply 3x plus 2 times another 3x plus 2. You can use the smiley method or smiley face method or FOIL method to multiply it out. You get 9x squared plus 12x plus 4, and then the plus the 1 at the end gives you 9x squared plus 12x plus 5. So your A, your B, and your C are your 9, 12, and 5. It wants the complete form, 9x squared plus 12x plus 5. Now it says, here's a function equation, f of x equals g of 7. Your f of x was 3x plus 2. G of 7 gives you 7 squared plus 1, which that combines to give you 50. Solve for the x, you get 3x equals 48, x equals 16. Now they want you to find the inverse function. So remember, here's f of x, y equals 3x plus 2. Switch the x and y, and then solve for y. So we subtract the 2 over here, so you get x minus 2. Then divide by the 3, and you get x minus 2 over 3. That is your inverse function. More functions. Find g of x divided by f of x plus x, and they want us to combine it into a single fraction in terms of x in simplest form. So g of x is x squared plus 1, f of x is 3x plus 2, plus we're going to put x over 1 to make it a fraction. Now we want a common denominator, so we multiply the numerator and the denominator by the 3x plus 2. Now we have a common denominator of 3x plus 2. Over here, because we already had the common denominator, you're just left with x squared plus 1. On the right-hand side, since we had to multiply by 3x plus 2, we need to distribute the x, the positive x, distribute it, and you get 3x squared plus 2x. Now we can combine like terms. We get 4x squared plus 2x plus 1 all over 3x plus 2. And here for letter G, we have this kind of tricky inverse function question. It wants us to find the value of x when the inverse of h of x is 2. Well, you might start off with your h of x equaling 4 to the x power. You switch your x and y, but then when you go to solve for y, you actually can't do that unless you know how to use logarithms. And logarithms are not taught in the IGCSE level, they're taught up in the A level. So I'm going to assume that you don't know how to use logarithms, how to do this. So there is another way that you can do it because of the relationship between functions and inverse functions. When you change from a function to the inverse function, there are three things that are true. First of all, they're symmetrical over the y equals x. Second of all, your x and y switch values going from the function to the inverse function, and your domain and range also switch. So the one that we're particularly interested in is that our x and y value switch places. So if the 2 is the function value, that means the y value of our inverse function, then that means the 2 is the x value for the regular function. Okay, so your function x and y switch for the inverse function. So if we start with the y value, the 2 of the inverse function, then that means it is the x value of the regular function. So what we really are looking at is h of x, plugging in the 2. So h of 2 is 4 squared, which is 16. Notice it's only worth 1 point. So I don't think they're actually expecting you to use logarithms and calculate it out algebraically or using the logarithms. They want you to understand the relationship between the function and the inverse function and calculate it this way. It's kind of a recognition type question. That's why it's only worth 1 point. Moving on, number 7, Tanya plants some seeds. The probability that a seed will produce flowers is 0.8. So notice down here, here's produces flower. 0.8 yes, 0.2 no. Remember, every branch set has to add up to 1. Then when a seed produces flowers, that means now we move on to this second branching here. The probability that the flowers are red is 0.6, and the probability that the flowers are yellow is 0.3. So here we have our red 0.6, the yellow 0.3. That means the other has to be 0.1, again, because they all have to add up to 1. Every branch set has to add up to 1. So 1 minus the 0.6 and 0.3, which is 0.9. 1 minus 0.9 is 0.1. Now, Tanya has a seed that produces flowers. In other words, there's already flowers there. So we're not dealing with the first branch, we're dealing with the second one. Find the probability that the flowers are not red and not yellow. This is kind of a hint also how you can calculate this part right here. But if it's not red and not yellow, the not an event is 1 minus the probability of the event. So if it's not red and yellow, it's 1 minus the probability that it is red or yellow. So 1 minus 0.6 plus 0.3 is again the 0.1. That's how you get this 0.1 down here. So these two kind of correspond depending on which one you looked at first. Part 2 here, or part II, find the probability that a seed, so now we're starting here at the beginning, it has not flowered yet, we're at the seed point. Find the probability that a seed chosen at random produces red flowers. So we have to go down this pathway here, all the way from seed to flowering, yes, and then becoming red. So that's 0.8 times 0.6 is 0.48. Then Tanya chooses a seed at random. Again, it's starting at the seed point, not at the flower point. Find the probability that the seed does not produce red flowers and does not produce yellow flowers. So there are actually two pathways where you can go and get a not red or not yellow flower. You can either get a flower that is of a different color, or you can have a seed that does not flower at all. Of course, if it does not flower, it won't be red and it won't be yellow either. So we need this 0.2 for the not flower, and then we need to follow the pathway to get to the other color. So that's the 0.8 times 0.1. So here we have the 0.2 for the not flower plus the 0.8 times 0.1 for the pathway to the other color, or the color that's not red and yellow. You add those together and you get 0.28. Letter C, 2 of the seeds are chosen at random. Find the probability that one produces flowers and one of the seeds do not produce flowers. So these 2 seeds can be in 2 different orders. You can have the seed first that produces flower and then not flower, or the first seed could be the not flower and the second is the one that produces flowers. So the produces flowers is 0.8 times the seed that does not produce flowers is 0.2, and you get a total of 0.16. If you switch them around, you still get 0.16, but it's through a different order, and we add those together, those 2 possible ways of getting the outcome, and the probability becomes 0.32. Moving on to number 8A, here we have these mathematically similar triangles, and with lengths of 8 to 12, that's kind of our ratio there, 8 to 12. And it gives us the area of the little triangle is 16, and it wants us to calculate the area of the big triangle. Well, first, let's start with the ratio that they give us. They give us a ratio of 8 to 12, which reduces to 2/3, and that is a length. That is one dimensional, that is the dimension of length. And we want to go to area. So we need to square this ratio to get our ratio for 2 dimensions or area, and that we do that by squaring it, and we get 4 to 9. So now our ratio is 4 to 9, and we set that equal to the little triangle has an area of 16 divided by the area of the big triangle, which we do not know. Now we can just cross multiply, so we get 4x equals 144. Divide by 4, the area of the big triangle is 36. Now it says here, the triangles are the cross sections of prisms. So now our little flat 2-dimensional objects are now becoming 3-dimensional objects. They're still mathematically similar. Now it takes us to volume. Volume is 320. Calculate the length of the larger prism. Well, let's go back to our original length between the 2 triangles, which are cross sections. And so our original 1-dimensional ratio is 2 to 3, except now we want to go to volume. So we're going to cube this ratio, and that gives us a volume ratio of 8 to 27. Set that equal to a fraction with the volume of the smaller prism going on top, the 320, and the larger one going on the bottom. Again, cross multiply. The volume of the larger prism is 1080. That is not our answer. It is not asking for the volume of the larger one. It is asking for the length along the larger one. So if you take volume and you divide it by area, that gives you length. So here's the volume, the 1080, and the length of the larger prism was 30. Okay, so where did I end up at? Oh, sorry, the length So sorry, the area of the triangle PQR was 36. So volume divided by area, volume, we already calculated 1080. The area of our larger prism, okay, again, the area for the larger representative cross-section triangle is 36. So divide by 36, and that means the length of our prism is 30 centimeters long. Going on to part B, a cylinder with radius 6 and height h has the same volume as a sphere with radius 4.5. Find the height. So first we start with our volume for a sphere is 4/3 pi r cubed. The r is 4.5. Plug that in, calculate it out on your calculator. Use the pi key. Don't use 3.14. Don't use, what is it? Is it 28 sevenths or whatever? Not 28 sevenths, 20. I forget the fraction now that some people use for that pi value. Left my mind. I don't usually use that, but some people do. Use the pi key on your calculator. And so 4/3 pi times 4.5 cubed, you get 381.7. I think 22 sevenths was the fraction that some people use. Anyway, use the pi key. And now going to the cylinder, a cylinder has a volume of pi r squared times the height is cylinder volume. Pi r squared times the height. The r is 6 for the cylinder, and our volume over here is 121.5 pi. I had put 381.7, but to do that gives you all those decimals. So if you just keep the pi and calculate the numbers here, I just got done telling you to use the calculator key. If you keep the pi symbol and calculate the numbers, you get 121.5 pi. And because we're solving for the height, we're going to divide by this pi over here. So instead of converting them into decimals, we can just leave that irrational number as a variable, pi, and it will divide by 36 pi. The pi's cancel, which then gives us 3.375. Notice the decimal does not run off the end of your calculator, meaning this is an exact calculation. So you don't go by the three significant figures when you have an exact calculation. So 3.375 is the answer that you should get. And again, it's helpful in this case if you leave the pi as a variable instead of changing it to its decimal form. Part C, a solid metal cube of side 20 centimeters is melted down. So, okay, here's our cube, side cubed, so 20 cubed is 8,000 cubic centimeters. It's now melted down, so you've got the same volume, but separated into 40 solid spheres. So divided by 40 gives you 200 cubic centimeters per sphere, each with a radius of r. So here is our sphere formula, 4/3 pi r cubed for one sphere equals 200 cubic centimeters of volume. We want to solve for the r, so we divide by 4/3 pi. And yes, in this case, we can use the decimal version, get 47.749. Then cube root that and get 3.628. To three significant figures is 3.63. Letter D, a solid cylinder has radius x and height 7x halves centimeters. The surface area of a sphere with radius capital R centimeters is equal to the total surface area of the cylinder. So here is our total surface area of the cylinder, 2 pi r squared. So pi r squared is a circle. We do 2 pi r squared because that's the top and the bottom of the cylinder. They're both circles. The radius is x, so that's where this x comes from. So 2 pi x squared, that's the top and the bottom. Then the side of our cylinder is the circumference, 2 pi r, times the height, so the 7x over 2. So this left-hand side of the equation is the cylinder. It is equal to the total surface, the surface area of the sphere. So we get with this one, 2 pi x squared. Oh, this right here is just simplifying it. Notice the 2's cancel over here. So for this front part, 2 pi x squared. For this back part, 7 pi x squared. Notice they are like terms, so that gives you 9 pi x squared. That is the cylinder part of the equation. Then for the sphere part, 4 pi r squared. Now with the radius of capital R, we want to solve for the capital R in terms of x. Notice don't use again your pi as a decimal because they can cancel out. So we end up with 9x squared over 4, and we want to square root that to get R by itself. So we get the square root of 9/4 x squared, which reduces, of course, we want the positive root because we're dealing with radius, which is a distance. And square root does distribute over, multiply, and divide. So square root of 9 is 3, square root of 4 is 2, square root of x squared is x. So this is the legitimate way of distributing a radical. And so we end up with 3/2. X is our radius of the sphere in terms of x. Going on to number 9i, write x squared plus 8x minus 9 in the form of x plus k squared plus h. So we want to, this is the complete the square form. We're going to move this -9 over because it doesn't give us a perfect square when we factor. Then we do the complete the square formula, which is the negative, or which is the, sorry, the b over 2 squared. Here's the b term, a, b, c. So the b term is 8. Divided by 2 is 4, squared is 16. So this plus 16 is the magic number that allows it to factor into a perfect square. And we have to equalize over here to maintain our equality of this expression. And -9 minus 16 is -25. So our complete the square form is x plus 4 squared minus 25. Now it says to use our answer to part A to solve this equation. So we're going to exchange the x squared plus 8x minus 9 with the answer to our part A, part I, x plus 4 squared minus 25, and set it equal to 0. So in this case, you don't have to multiply it all out, or you're going to end right back where you started. In this case, we're going to solve for x by undoing our mathematical operation. So we'll add the 25 to the other side, square root both sides. Don't forget the plus or minus. There are 2 answers to this quadratic. And then subtract the 4. So we have x equals -4 plus 5 and x equals -4 minus 5, which gives us x equals 1 and x equals -9 as our 2 answers. Now it says that once you've worked through this, they're kind of hoping that you can figure out how to go backwards. So the solution to this x squared plus bx plus c equals 0, which is kind of like what you were doing up here. Are these two answers here, which is kind of like the two that you had here, they want you to work your way back to this. So we have x equals this one, and we have x equals that one. Notice x equals, there's our answers, and these are the solutions. So we start off with x equals, multiply the 2's to the other side. And if you notice, when we add 7 to both sides, we end up with our 2x plus 7 and the plus or minus root 61. That's like this right here. Okay, notice x plus 4 and plus or minus 5. Here we have 2x plus 7 on the left and the plus or minus root 61 on the right. So we can square both sides. So we get 2x plus 7 squared equals the 61. And now we can move the 61 over and we can multiply it all the way out. So 2x plus 7 squared is the 4x squared plus 28x plus 49, and then the minus 61 at the end. Again, be careful. Don't distribute exponents over add and subtract. You have to take 2x plus 7 times 2x plus 7 and do your smiley face or FOIL method to get these three terms here, followed by the minus 61. Combine your like terms and notice it wants x squared plus bx plus c, so there's no coefficient on the x squared. So when we put this together, we get 4x squared plus 28x minus 12 equals 0. We can divide all those by 4 to get rid of that coefficient in the front or to reduce it to a 1. So we get 1x squared plus 7x minus 3 equals 0. So it wants the value of the b and c. So the b is 7 and the c is negative 3. Moving on, here's a diagram. It says sketch the graph of y equals x minus 1 squared. Well, remember that this is vertex form. So the vertex is change. The sign of this gives us 1. The outside number is an understood 0. So you have 1, 0 is your vertex. Over 1, 0 right on the x-axis is your vertex. And you can plug in a point. So if you plug in 0, you have a negative 1 squared, which then becomes a positive 1. And if you reflect that over your axis of symmetry, which runs through your vertex, you just go over 1 to get to the axis of symmetry, go over 1 again. There's your third point. You can graph more points if you want. So here's our parabola. Sketch the graph of y equals 1/2 x plus 1. This is your line formula, crosses the y-axis at positive 1, has a slope of up 1 over 2. So here's up 1, here's over 2. Run your line through it. Now it wants us to find the intersection of A and B, points A and B, and then find the distance between the two. Notice it's 7 points. So this is going to be a little bit involved to get those 7 points. So first of all, we need to, before we can do the distance, we need to do the intersecting. So intersecting, if these two graphs intersect, then that means this y value is equal to this y value. So x minus 1 squared is equal to 1/2 x plus 1. Multiply out your x minus 1 squared, you get x squared minus 2x plus 1 equals 1/2 x plus 1. You can subtract 1 from both sides. Notice we have a fraction here with a 2 in the denominator. So we're going to multiply everything by 2 to get rid of the fraction. That gives us 2x squared minus 4x equals x. Subtract x to the other side gives us 2x squared minus 5x equals 0. Factor in x out gives us, or just factor it, gives us x times 2x minus 5. Set both of those equal to 0. So we get 0 and 5/2. Plug those back in to, say, like this one. If you plug in 0, you just get 1. So that one was easy. Plug in the 5/2, so that one takes a little more work. 1/2 times 5/2 plus 1 is 9/4. So here now is our points A and B, the coordinates for each. Now we can follow the distance formula, and x2 minus x1 squared plus y2 minus y1 squared. Doesn't really matter the direction as long as you go the same direction for both your x and y. So you could have done 5/2 minus 0 squared plus 9/4 minus 1 squared would have been fine. Just make sure you go the same direction for both your x and y. Plug those in, do the subtraction first because they're in parentheses, then do the exponents and then add them together because radicals don't distribute over plus or minus. Then do the square root at the end and you get 2.795, which rounds up to 2.80. You need to put the 0 because it's 3 significant figures. So your 79 is rounding up to an 80, 2.80. Number 10a, y to the 4th minus 4x cubed. Find the value of y when x equals a -1. So just plug in a -1. -1 to the 4th power is +1. -1 cubed is still -1 times the -4 becomes +4. 1 plus 4 is 5. Then find the two stationary points on the graph of y equals x to the 4th minus 4x cubed. So again, a stationary point is where you have a curve that is either a maximum or a minimum, and the slope at the maximum point or at the minimum point is horizontal line, meaning the slope is 0 at those points. So to find slope of an algebraic expression, we're going to use the first derivative. So the first derivative is, and so we can use y prime. There's other designations like dy dx or d over dx times the y. There's several different ways of notating it. The simplest way is just y prime. So the formula for deriving algebra is to multiply the exponent to the front. So that's 4 times 1 is 4, and then subtract 1 from the exponent gives us 3. Do the same thing on the second term. 3 times -4 is -12, and subtract 1 from the exponent gives it a 2. So this is our first derivative, our slope, and we want to set it equal to 0 because that's how we find the maximum and minimum points, which same thing as the stationary points. And so we factor out if 4x squared is common to both, and when you factor that out, you get x minus 3. Set both of those equal to 0. When you take 0 divided by 4 and square rooted, you still have 0. When you add 3 to the other side, you get 3. Those are the two x components, 0 and 3. Notice they want the y components as well. So plug it back into the original equation. So if you plug the 0 first, you get 0 again. If you plug in the 3, you get a -27. Notice that was 6 points, so there is a little bit of work expected for that. Now we move on down here, and it gives you the original, but with variables for exponents. Now it gives you the derivative. Notice it used the designation dy dx instead of the y prime. Same thing, dy dx is using differentials. And so now you have the slope, and they want you to go back to the original, meaning they want you to use this derivative formula backwards, okay? So remember, you multiply to the front and subtract 1. So we're going to go backwards. We're going to add 1 and then divide by the number. So if we add 1 to the 10, that gives us the 11. That's where the 11 in the front came from. Add 1, you get 11. Divide by the number, the 11s cancel, and you just get x to the 11. So if you go forwards, 11 multiplied by the front is 11, subtract 1 is 10. Okay, so we went the other way. We added 1 to get the 11, divided by that 11 to undo what was multiplied to the front. So we're going to do the same thing here. Add 1 to the exponent gives us 5. Now we're going to divide by 5 to cancel out the part that was multiplied to the front. 10 divided by 5 is 2. Can check it by going forwards. 5 times 2 is 10. Subtract 1 gives you 4. So you want to think a little bit of forwards and backwards between derivatives, and this is actually called integration here. It's going backwards through your derivative formula. So your exponents P and Q are 11 and 5. Actually, you didn't really need to calculate the whole integral. They just wanted the exponent part. So if you saw that you subtracted 1 here, then all you have to really do is add 1 here, and you get 11 and 5. But it's also good to know how to handle the coefficients. You only needed the exponents, 11, 5. So that takes us to the end, and that again is our IGCSE May-June series of paper of 2020, paper 42. Remember, 2020 starts the new syllabus series. So as always, thank you for joining me, and I hope to see you again next time.